All right, so today is the second lecture. So here we are going to solve some of the problem and the concept of this problem you learned in the last lecture. Okay, all right. So the first one is this one. So the first one says the Mount Everest at 29,028 feet is the tallest mountain on the earth. What is its height in kilometers? Okay, so we have to convert, basically here we have to convert a number in feet into kilometers. Okay, now to convert this number, I mean this 20,028 feet into kilometers, the first thing we need to find is the relation between feet and kilometer. And in the textbook it gives us this relation: 1 kilometer is equal to 1 kilometer is equal to 3.281 feet. Okay, so 1 kilometer is equal to, actually not 3.3281 feet. Okay, so this is the relation the textbook gives us. Okay, now as you remember from the lecture, the first lecture, the first thing after we know what is the relation between the two units, the next thing is to do is make a fraction of 1. Okay, so the fraction of 1 will be either this or this. Okay, so once we have that, then the next step is this 29,028 feet. Okay, so we have to multiply it by 1. Okay, and then find one of this relation to substitute for 1. Okay, and we have to choose it carefully, okay, so that we can cancel feet here in the numerator. So I mean we have to find 1. We have to cleverly choose 1 so that we can cancel this feet with the feet, and our result is in kilometer. Okay, so the good choice will be this one. Okay, because feet here is in the denominator. So because the feet here is in the numerator, we need feet in the denominator to cancel it out. And then you see that if you substitute with this 1 kilometer, 3,281 feet, you see that feet and feet cancel out, and our result is now in kilometers. So the only unit left here is kilometer. So now if you divide this by this, okay, 29028 divided by 3,281, so this will be in kilometer, because only thing left here is the kilometer. So if I do this math in calculator, I get something like this: 8.847 kilometer. Okay, so the result here is 8.847 kilometer, although here I didn't take care about the significant figure. Okay, all right, let's move on. So the next question is my apartment floor is 880 square feet. What is the area in square meter? Okay, so we have to convert 880 square feet into square meter. Okay, so let's see how to solve this problem. Okay, so the first thing here we need to find is a relation between feet and meter. Okay, feet and meter. So if you go to your textbook, front or back cover, you probably find the relation. Okay, and the relation is 1 meter is equal to 3.281 feet. Okay, so same thing we have to same thing as the first problem. We have to first make a fraction of 1. So the fraction of 1 will be something like this: 1 meter 3.281 feet, or 3.281 feet by 1 meter. Okay, all right, so this is the fraction of 1, so either this one or this one. Now the next thing we have to do is 880 feet square or square feet. Okay, now here we have to be careful. Here we have feet and feet. Okay, so what it means we have to convert feet twice. Okay, in the last problem we convert feet one time. Here we have to do it 2 times. Okay, so to convert feet into 2 times we need 1. Okay, so we can do this. I mean, we can do this, right? Because something multiplied by 1 is 1, and if you multiply again by 1, you get again the same thing. So multiplying by 1 or many 1, it does not matter. So here we need 2 1, because we have to convert feet twice. Okay, so again we have to choose carefully so that we can cancel feet square in the numerator here. Okay, so that means we need feet in the denominator. So the correct choice again will be this one. Okay, so 880 feet square times 1 meter 3.281 feet, 1 meter 3.281 feet. Okay, so you see that 1 feet, 2 feet cancel with feet square. Okay, so we are done. So what we have to do is now do this math using our calculator. 3.281, 3.281. Okay, so we have to divide 880 by 3.281 twice. Okay, use bracket, okay, here to get the correct answer. So now you see that our answer is in meter and meter. So 2 meter is meter square. So if you do this correctly, you probably get something like this: 81.75 meter square. Okay, again, I'm not here, I'm not caring about the significant figure. Okay, all right, 81.75 meter square. Okay, so you see that we have square, then we have to convert it twice. Okay, we need 2 1 and 1. Okay, other than that is exactly the same as the first problem. All right, let's move on. All right, so the next problem is so suppose that you drive 10 kilometers from your university to home in 20 minutes. Okay, calculate your average speed. Okay, so we'll be learning average speed in the next chapter, but here it gives us some definition of average speed. So let's use this and then calculate the average speed, and we'll be learning more about average speed in next class, I mean in next chapter. All right, so average speed It says the average speed is the distance travel divided by the time of travel. So let me call it speed. Okay, speed s equal to the distance d time t. So let me call speed equal to d by t. Here s is the speed, d is the distance, t is the time. Okay, so what we have here is 10 kilometer is the distance and 20 minutes. Okay, so this is the speed. Okay, so distance is 10 kilometer, t is time, and that is 20 minute. So if I do this math, we get 0.5. Okay, 0.500 kilometer per minute. Okay, so that's okay. The next thing we have to do is we have to find, we have to convert this speed into kilometer per hour and be in meter per second. Okay, so let's see how to do that. Okay, so the first problem is we have to calculate it into kilometer per hour. So here you see the kilometer minute, next is kilometer per hour. So we don't need to convert kilometer because it is already kilometer. So we have to here convert minute to hour. Okay, now as you know that 1 hour is equal to 60 minutes, right? So we can use this conversion factor and convert kilometer minute to kilometer hour. So the first thing we have to do is write a conversion factor, the fraction of 1, and it could be this or this. Right? Now 0.500 kilometer per minute times 1. So we can write that. So 0.500 kilometer per minute. Okay, now here we have to choose carefully. Okay, so that we can cancel the new minute in denominator, and our result will be in kilometer per hour. Okay, so to cancel minute in the numerator, we need this one. We need this one because now here minute is in the numerator. Okay, so if you use this one, it will be incorrect. So the correct choice is the second one. So it is 60 minute per 1 hour. Okay, so you see minute and minute cancel out. Now our result is 0.500 times 60 kilometer per hour. So that is 30 kilometer per hour. Okay, so you see that 0.5 kilometer per minute is 30 kilometer per hour. All right, now the next one is we have to convert this one into meter per second. Okay, so let me erase this. Okay, so now we are going to do B. Okay, so here I'm going to convert this number in kilometer per minute to meter per second. Okay, so here we need two conversion unit. One conversion unit is 1 kilometer is equal to 10 to the power 3 meter. Okay, so from your textbook you can find this relation, and also we can find that 1 minute equal to 60 seconds. So this is common sense, everyone know this one, right? Now then we have to make two conversion unit, one from this one and another for this one. Okay, so 1 kilometer over 10 to the power 3 meter, or 10 to the power 3 meter 1 kilometer. So this is one conversion unit. Another conversion unit, I mean the fraction of 1 is this. Okay. So then 0.500 minute, sorry, kilometer per minute. Okay, so here you see that you have to convert kilometer, you have to convert minute. So to convert kilometer you need one, and to convert minute you need another one. Okay, so 0.500 kilometer per minute. Okay, so now to convert kilometer from the numerator, we need kilometer in the denominator. So the correct choice is this one. 1 kilometer 10 to the power 3 meter. And to convert it to cancel minute in the numerator, denominator, we need minute in the numerator, right? So this is the correct choice, because here we have minute in the denominator, we need minute in the numerator. So the correct choice is this one. Okay, now cancel kilometer minute. So what we have here, 0.500 times 10 to the power 3 divided by 60, and then only thing we left with is meter here and second here. So you see that now our result is in meter per second. Now if you do this math in your calculator, you should get something like this, 8.33 meter per second. All right. All right, so let's move on. Let me erase this and move to the next problem. All right, so here what it says. So it says a grocery store sells 5 lb bags of apple. You purchase 4 bags over the course of a month, and here the list of the weight of each bag you bought in 4 different weeks. Okay, so the first one was 4.8 lb, the next one is 5.3 lb, and then 4.9 lb, and then 5.4 lb. Okay, and you determine that the weight of the bags has an uncertainty of plus minus 0.4 lb. Okay, what is the percent uncertainty? Okay, so the percent, so you see that this is the central value. So here this is the central value and this is the uncertainty. So we want to know what is the percent uncertainty. Okay, so the percent uncertainty is equal to uncertainty, right, divided by the central value, okay, times 100%. So this is equal to 8%. So here we have uncertainty of about 8%. Okay, very simple. The next question is exactly the same. Here it also asks us to calculate the percent uncertainty. So let's do it again. Okay, so again the percent uncertainty is uncertainty over the central value. So you see that a good quality measuring tape can be off by this centimeter over a distance of 20 meter. So 20 meter is basically the central value here, and uncertainty, because it says that it can be off by this centimeter. So this is the uncertainty times 100%. Now here there is a problem. The problem is we cannot do mathematical operation into two different units for the same quantity. Okay, so here you see one is in meter, another is in centimeter. So if you do that, the result will be incorrect. Okay, so to do this operation, to do this math, we have to convert either meter to centimeter or centimeter to meter. Okay, now in your textbook you can search and the relation between 1 meter to centimeter. So 1 meter to centimeter is 10 to the power 2 centimeter, or 1 centimeter is actually your textbook gives something like this. 1 centimeter is equal to 10 to the power minus 2 meter. Okay, so let's convert centimeter to meter. So it's basically because it okay, so because we have this centimeter, we can convert either following the rule we use in problem 1, 2, 3, or you can just here it's very simple. So you have to convert centimeter to meter, and 1 centimeter is this meter, so 0.50 centimeter, just you have to multiply by multiply it by 10 to the power minus 2 meter. Okay, so now it's easy. Okay, now because they're in the same unit, you can do this operation. So if you do this operation, your result will be in this. So your result will be this. Okay, so the uncertainty here is 0.025%. All right. Okay. Now this is about significant figure. All right. So perform the following calculations and express your answer using the correct number of significant figure. Okay, so it says that a woman has 2 bags weighing 13.5 pounds and 1 bag with weight of 10.2 pounds. What is the total weight of the bags? Okay, so she has, so number A, she has 2 bags of 13.5 pounds and 1 bag of 10.2 pounds. Okay, so the total weight will be so this is 27.0 and then 10.2, so it will be 37.2 lb. Okay, because this is in 3 significant figure, this is in 3 significant figure, so our final answer should be in 3 significant figure. So the final answer will be this 37.2 lb. Okay, number B. All right, so the force of an object is equal to its mass multiplied by its acceleration. So this equation we will be learning in chapter 4. Okay, but for the time being, let's just follow the instruction of this question. Okay, if a wagon with mass 55 kilogram and accelerate at this accelerate at a rate of this meter per second square, what is the force? Okay, so force is F and the mass is given, mass is 55 kilogram. Okay, and acceleration is 0.0255 meter per second square. So here you see that this one is in 2 significant digit, this is in 3 significant digit. So our final result will be in 2 significant figure. Okay, so if you do this math in a calculator, it will give you 1.4025, and unit for force is Newton. Okay, so you will learn that. Okay, but in correct significant figure, the result will be just 1.4 Newton. Okay, because this is the least significant figure and it is 2, so our result should be in 2 significant figure, so the result is 1.4 Newton. Okay, so if in some example, in some exercise in bright space, if it is written that written explicitly that submit your answer in correct significant figure, then you have to follow the rule of significant figure. Otherwise, you don't need to worry about it. All right. So let's move on. Okay. So let's do number 8. Okay. So here I want to know whether this equation is correct or not. Okay, so you will be learning similar equation in next chapter, but even we don't know how to derive this equation. Just by knowing the dimensional analysis, we can check this equation whether it is correct or incorrect. Okay, so in this equation here, v is the velocity or speed. So v is some speed, final speed. V0 is the initial speed, a is the acceleration, and t is the time. Okay, so so the dimension of t, okay, so the dimension of that dimension of t is this, that we already know. Okay, now v, the dimension of v and v0, they are the same, and that will be L over t. Okay, L over t is for the velocity or speed, any speed, it doesn't matter whether it is initial or final. And for acceleration, it would be L over t square. Okay, so these 3 dimension we need to solve this problem. Okay, now here you see that the left hand side is just v. Okay, so the dimension of v is L over t. Okay, so it tells us the right hand side, all the quantities in the right hand side should be in this dimension. Okay, so let's check the right hand side. So right hand side, so v0, so one of the quantities is v0, and we know that v0 is, okay, so first term, right hand side, first one, and v0 means again L over t, so that makes sense, right? L over t, so it matches with the left hand side, right? Now right hand side, term 2, so term 2 is half a t square, right? Half, the number does not have any dimension, so we don't need to write the dimension when you check the dimension, dimensionality of an equation. So the next thing is a, the dimension of a is L over t square, and then time t square means t square. So here you see that this t square cancel out this with this t square. So the dimension of the second term in the right hand side is just L, okay, which does not match with this one, right? This is L, this is L over 2, L over t, this is L over t. Okay, although the first term is correct, the second term somehow is not correct, okay, because its dimension is L. So this equation is not a correct equation. Okay. All right. So so this is how we check the dimensionality of an equation, or whether an equation is correct or not. Okay. So here the left hand side is L over 2. The first term of the right hand side is L over 2. That makes sense. But the second term of the right hand side is the dimension of the second term of the right hand side is just L, which does not make any sense. Okay, so that's why this equation is incorrect. Okay. Now let's do the next one. So here again we are given an equation. So we have to determine the unit, dimension, and unit of A and B. So as you know, that dimensional analysis can be used to check whether an equation is correct or not, and to check to find the dimensions and units of unknown quantities. Okay, so here A and B are two unknown quantities, and V, the velocity or speed, we know. T is the time, we already know. So we can represent our dimension of A and B in terms of the known quantities, and known quantities here are V and T. Okay, so again, similar to the last problem, so V, the dimension of V is L over T, and the dimension of T is just T. Okay, now the left hand side is V, so its dimension is just L over T. Okay, right hand side, first term, A T cube. Okay, so A we don't know, T cube means this. Okay, so because the left hand side dimension is L over T, so this whole thing's dimension should be equal to L over T. So if so, then this equation is correct. Okay, so let's say A over T cube's dimension should be equal to L over T. Okay, so if its dimension is equal to L over T, then this equation is correct. Now, if you solve this equation, you see that if you divide both sides by T cube, okay, you see that we have the dimension for A that is equal to this, L over T4. So the dimension of this unknown quantity is L over T4. And as L is the distance, and distance is measured in meter, and T is second, and T is time, and time is measured in second. So the unit, the standard international unit for A is meter per second to the power 4. Okay. All right. Now let's do the same thing for the second term, to learn about the dimension of B. Okay, and that is B we don't know, and T is the dimension of T. Now this equation is correct if BT is equal to the dimension of the left hand side, and that is L over T. Now if you divide both sides by T, you get B, and that is equal to T to the power T square. Okay, so the dimension of B is L over T square. And now if you write the unit of L, so unit of L is meter and unit of T is second. Okay, and because we have square, so we have second square. So this tells us that the unit, standard international unit for B is meter per second square. Okay, so you see that we can determine the dimension and standard international unit if we know how to analyze dimensionally. Okay, let's move on. So this is the last problem, number 10. So I'm not doing this one, number 11, just 10. Okay, so here we have two equations. So we'll be learning about this later, the time period of a pendulum. Okay, for the time being, just say that we have two equations, this and this. Okay, so this and this. We have to check which one is correct. Okay, so in one equation, we have 2 pi square root L over G, and another equation where we have 2 pi square root G over L. Okay, so we have to check which equation is correct. Okay, here T is the time period. Okay, so the time periods unit should be time. So this is time. 2 pi is just a number, so it does not have any unit, so you can ignore that. L is the length, so its unit, I mean its dimension is just the dimension of length or distance. And here G is acceleration. Okay, so acceleration's unit is L over T square. Now by using these three, we have to check whether first equation is correct or the second equation is correct. Okay. Now, left hand side for both is T. So this is the left hand side. So we have to check basically the right hand side for first equation and second equation. So right hand side for the first equation. So it is square root of L over G, right? 2 pi. So 2 pi does not have any dimension. Okay, so I can ignore it. So it is L, and the dimension of G is L over T square. So this is the fractional line. So this is the middle line. Okay. So this L and this L cancel out. Okay. So we have something like this. 1. So this is the middle, and then 1 over T square. Okay. So if you do this math operation, you can show that this is equivalent to T square. Okay. So what it means, square root and square cancel out. So this is basically T. Okay. So it tells us that the left hand side is equal to the right hand side. So for this equation, you see that the right hand side is equal to T. The dimension of right hand side equal to T, the right dimension of right hand side and dimension of left hand side, both are T. So this equation is correct. So the correct equation is this one. So when you do the second part, you can check that that equation is not correct. Okay, so let's do it. Okay, so let's do the second part. So right hand side is 2 pi G by L. 2 pi does not have any, so this is L over T square and then L. Okay. So you can show that again, similar to that one, this L and this L cancel out. So our equation is, it looks like this. Okay, so square root and square cancel out, and we see that our dimension is 1 over T. Okay, which is different than the left hand side. So this equation is incorrect. So this is incorrect, this is correct. Okay, so here you see that how dimensional analysis can help us to check whether an equation is correct or not, and how dimensional analysis help us to determine the dimension of unknown quantities and unit of unknown quantities. Okay, so with this, I am going to stop for this lecture, and in the next lecture I will be talking about chapter 2. Okay, so chapter 2 is about kinematics. Okay, so there I will be discussing about the speed, velocity, acceleration, and then something called kinematic equation. So in the next lecture we will be learning all of that. All right, so I will see you in the next lecture. So that's it for today.